Well, thanks to the organizers for having me. I'm Todd Lensman. I'm a graduate student at MIT. I'm going to present some preliminary joint work with a classmate of mine, Rebecca Dix, on potential competition, incumbent innovation, and clean transition. So the broad motivation for this project is kind of an old question in economic growth, thinking about the relationship between competition and innovation. There's pretty rich literature that is formed that can study this question, and it typically takes the approach of thinking about innovation in terms of the intensity of innovation or investment in innovation. So it considers situations in which firms are kind of fundamentally using one kind of technology. Different firms have different qualities of this technology, and they make investments in order to improve that quality. So kind of questions that you can ask in that kind of a framework are: do incumbents invest at it to a greater or larger or a smaller extent than entrants? How does this depend on the quality gap, etc. The perspective that we're interested in taking in this project is a bit different. We're thinking about how competition will affect the choice that different firms have with the technology to innovate. So thinking more about the direction as opposed to the intensity. The particular dichotomy that we're going to be thinking about in this project is that between old and new technologies. Where we'll kind of precisely think about old technologies as those that are kind of currently dominant in a particular industry. So they're used by incumbents to produce output and generate profits. But they're kind of farther along in kind of their life cycle than other technologies. So they're subject to only slow improvements through innovation. Alternatively, new technologies currently lag, so they're kind of not quite cost competitive with the old technologies yet. They're available to both incumbents and entrants to produce, and they're subject to much faster improvement because they're earlier in their life cycle. So the more specific question that we'll think about here is: what is the relationship between competition, between incumbents and entrants, and then the choice of technology to innovate? So to kind of bring this to the context that we're interested in here, the clean transition. We're going to follow in a kind of a recent line of papers that makes the point of this technology choice perspective captures a key feature of clean innovation. So in particular, in lots of industries or product classes, like you can see here, there are kind of very clear old technologies, which in this context are dirty ones, and then very clear new technologies, which tend to be clean ones. So the two industries that we're going to focus on today are thinking about the energy production and auto industry. So for the energy production industry, for example, the old technologies that we have in mind here are ones basically fossil fuel technologies, or any kind of related technologies that are dedicated to cleaning up fossil fuels to some extent, but kind of perfectly capture. The alternative here would be renewables, solar, hydropower, wind, etc., which are clean, but in many for many tasks or in many situations are not really cost competitive yet. People. And then similarly, in the auto industry, we'll think about the old technologies, anything involved with internal combustion engines, so conventional vehicles or hybrids, and then the new technology being electric vehicles. So kind of the similarities for these two industries are that kind of they're still currently dominated by some large incumbent firms that have been around for a while. So we're thinking in the energy industry, the fossil fuel companies, and in the auto industry, conventional vehicle manufacturers. But at the same time, these firms are being challenged by kind of entrant firms, which are innovating kind of newer technologies at quite a rapid pace. So the specific question that we're going to ask here, or there are two specific questions that we're going to ask, are: when do incumbents decide to preempt competition by innovating this new technology, versus postpone competition by more intensively innovating their old technology? So, for example, in the auto industry, we do see conventional vehicle manufacturers that are interested in producing electric vehicles. And then second, how does this competition determine the technology which gets developed in the long run? So is there a chance that we lock into an old technology, potentially slightly cleaner version of it? Or in the situation where we do end up transitioning, are we transitioning fast enough, or is the kind of incumbent bias leading us to delay too long? So I'll present kind of a basic set of empirical facts about the energy production and auto industry. So to do this, we're going to study patenting, we'll look at the patenting data in the energy production and auto industries. The sample of patents that we'll look at are going to be all those that are filed in the European Patent Office, the Japanese Patent Office, the US Patent Office from 1978 to 2015, just from the PASTET database. So we'll identify kind of our categories of old or dirty patents to new or clean technologies using technology classes, following a couple of recent publications, one of which should find many else. So as I mentioned, in the energy industry, our dirty collection of patents are going to be those related to fossil fuels or carbon capture. The clean patents are going to be related to renewables, and we're looking at a recent publication by the European Patent Office and the IEA, which kind of nicely define technology classes for patents that are related to these two categories. In the auto industry, following a recent paper to try to identify patent classes relevant for dirty technologies, so anything with combustion engine or our clean technology. So kind of in contrast to some recent work, we're fundamentally interested in a cross-industry comparison here. So thinking about incumbent versus entrant patenting behavior, does this differ between our energy and our auto industries? So we're going to argue that the answer is yes, and for particularly include increase. So to be a bit more precise, we're going to do, I think, a very simple exercise, and we're going to ask how does patenting early in the period, so the first half of our data from 1978 to 1996, how does it predict patenting behavior in the second half of the period, so from 1997 to 2015. So very simple long difference, looking at cross section or variation in the cross section. So we have a simple log linear specification here. So on the left side, I'm just taking the log of the number of clean patents that a particular firm F has in industry I in its post period. So we're just, how just the flow of clean patents in the post period. We'll regress this on a constant, and then basically the collection of information on this firm's patent portfolio in the pre-period. So the clean variable, which is on the right side, is going to be the log of the number of clean patents you have in the pre-period, log of 30 patents you have in the pre-period, and then a set of indicators that we need in order to deal with a couple of edge cases where if we have any clean patents or any 30 patents, in which case we can't find log. So there's a similar equation that we'll estimate for thinking about 30 patenting in the post-period. So we'll take the exponential of both sides, think about this as a Poisson model that will estimate the MLE, which is pretty standard for patent data. So the coefficients that we're going to be interested in here are going to be these the beta 1 coefficient, the beta 2 coefficient, which basically give us the elasticity of clean innovation in the post period to clean innovation in the pre period and journey innovation in the pre period. So when we run this regression, I'm just going to show you kind of the three coefficients that we're interested in here. We can do this for both sectors and for both categories here. The first thing to note is we get the kind of intuitive result that the best predictor of you doing dirty innovation in the post period is you doing dirty innovation in the pre period. So this is the spot these in the bottom row here, the highlighted elasticities tell us exactly this. And in the second row, the highlighted elasticities tell us again that the best predictor of clean innovation in the post period is clean innovation. So the empirical finding that we think is particularly interesting here are the highlighted ones in the bottom row. So if you focus on the energy industry in particular to begin with, it turns out that firms that did quite a bit of dirty innovation in the pre-period tend to not do so much clean innovation in the post-period. So if you look at the firms that were kind of top dirty innovators in the pre-period, it's going to be these conventional fossil fuel companies, ExxonMobil, Baker Hughes, Schlumberger, et cetera. And they're just not kind of interested in rushing into the renewable energy space. The picture is a bit different in the auto industry. So the top dirty patenting firms in the pre-period are actually the ones that are doing most of the clean patenting in the post-period. So conventional vehicle companies like Toyota, Nissan, Denso, et cetera, are kind of like the main players in electric vehicle patenting. So we think about this as being kind of like a qualitative difference between these two industries. And then the last set of coefficients that we could be interested in here are going to be the intercept firms, which actually just tell us about what the baseline rate of innovation is into these categories for the entrant firms, the firms that have no patenting activity in the pre-period. So in both cases, I guess I'd say in the energy industry, the entrants are kind of more intensively innovating clean technology than the dirty technology. The picture is kind of flipped in the auto industry, where entrant firms typically innovate quite intensively in both. So the takeaways are two. So the first, which I didn't show you for lack of time, is that in both industries, the entrants are innovating in clean technology more intensively than the incumbents. So if we just look at the portfolios that these firms develop, it turns out that they're just much more interested as a ratio of their as a ratio of their dirty innovation. Their clean innovation is just much higher. The second result, which is the one that I just showed you, is that auto incumbents are much more likely to innovate clean technology than energy incumbents. So the explanation that we'd like to suggest for this is that kind of what incumbents are interested in doing here is that in response to entry from a clean technology innovating firm, incumbents can decide either to also innovate on this clean technology in an attempt to kind of preempt that competition, or it can more intensively innovate its dirty technology, in which it has kind of an existing position, to try to postpone this competition potentially to. So in particular, this preemption you should expect to be more likely when the dirty and clean technologies are kind of similar to each other, in the sense that incumbents have some kind of basic intrinsic productivity advantage in the clean technology. So we think about the auto industry as being kind of an example for this, where I need to be able to produce a nice car if I want to produce an electric vehicle, and GM, Toyota, et cetera, have some baked-in kind of understanding of how to do that, which kind of Tesla or BYD had. So this is kind of a theory for in which industries we expect there to be kind of significant turnover in terms of the firms that are dominating, and whether there are interesting implications for the speed of transition. So we have a model in which we can start to think about these things. I'm going to present a very simplified version just in words now to give you a bit of an idea of the intuitions. So you can think about a one-sector innovation model in which there are just these two technologies, old and new, and there are two firms, just one incumbent and one entrant. So the incumbent can produce the output with either the old technology or its own version of the new technology, and an entrant can produce with its own version of just the new technology. The idea that the incumbent has an advantage, an insurmountable advantage. These technologies differ only according to their quality, or you can see productivity, and these qualities can be improved through innovation. We'll assume that the highest quality technology produces all output at each particular point in time, so these firms are really competing for the market, and the old technology is initially superior. The new technology, by contrast, features a higher rate of quality growth, so that if you're kind of innovating both at the same time, the new technologies eventually going to just assume that for the moment that both firms are just choosing the direction of innovation at t equals 0, and then you have a constant kind of innovation effort throughout. So given that the answer can only do one thing, our interest is really in trying to understand how the incumbent reacts to competition from the entrant. And there are two interesting cases that we can consider. So first, if we suppose that the incumbent has an initial quality advantage in the new technology, the only interesting kind of effect that competition can have on the incumbent is when the incumbent actually decides to switch from innovating its old technology to innovating the new technology. So it might do this in an attempt to preempt competition from the entrant, which it can do successfully, because if it has an initial lead, it won't lose that lead provided that it doesn't choose the technology. So the implication here is that we will see a particularly fast transition to new technology. This could be potentially inefficient because we're foregoing some productivity gains in the short run. And we'll see our incumbent maintaining dominance. The second case is the one where the entrant has an initial quality advantage in new technology, so that there's not a great degree of similarity here. In this case, what can happen is that the incumbent, without competition, will be interested in innovating new technology, but in response to entry, understands that in the long run that it can't be a perfect match. So in this case, the incumbent will redirect its innovation for the old technology. This has the effect of slowing our transition, potentially in an inefficient way, and we'll see turnover. So the basic implication that we like to take here is that competition between an incumbent and an entrant firm can imply a fast transition when the older new technologies are technologically similar, which we would argue is true in the auto industry, but is less true in the air. I'd like to conclude here. So kind of 2 points. First, our incumbent's response to competition can raise or lower medium-term growth, which depends on technological similarity. This is, we think, important for policy, and there are cases in the model where you can input a carbon tax that has some kind of ludicrous response. So, for example, it's entirely possible in this model to input a carbon tax that will actually slow your transition or forestall that transition entirely to a clean tech. So the full model that we're kind of developing at the moment is a fully dynamic endogenous growth model with repeated direction and intensity choices. We think it's important to have a fully dynamic model here so that our results are not going to be sensitive to timing assumptions on whether the entrant will be move first. I've also shown you these empirical case studies that suggest this kind of high technological similarity implies greater incumbent innovation in new technology. So we're working right now to think about a more systematic empirical test for this hypothesis, in which we can expand to other industries, develop a similarity measure using text analysis of patent data. And then finally, kind of all of the empirics that I've shown you so far are entirely internal to the patent data, which is kind of suboptimal since we're interested in competition. So we're kind of interested in building in some data from actual market data here to think about implications for things like hurdle prices. So happy to take any questions afterwards. But